now we'll take a look at how to actually graph an equation using, or how to graph the parabola just given the equation. So, like we've already talked about, really one of the keys about this form of the quadratic equation, known as vertex form, is that the vertex form gives you the vertex of the parabola. So the h and the k values together form the vertex. So the h and k values become the are the vertex of a parabola. So first thing we have to do, obviously, is identify what are the AHK values. So based on this parabola equation that we have here, we know that the a value is -1. Okay, the h value is actually -3. Okay, it's the opposite of this positive sign here, and the k value is +4. Okay, so what that means is that the vertex of this particular graph is going to be at -3, +4. Okay, and so we'll just quickly plot where that vertex is. So -3, +4 is right here. Okay. The direction of opening, because the a value is negative, the direction of this is actually going to go down. Okay. The equation of the axis of symmetry is always equal, or is always the same as x when x is equal to h. So the h value here is 3, so the axis of symmetry is x equals -3. We need now to actually graph this thing. So we can't identify the optimum value. Actually, we can't identify the optimum value because the optimum value is always equal to the k value. So the optimum value is +4. But we can't identify what the x-intercepts are until we figure out, well, what is the step pattern? Okay, and in this case, the step pattern, the a value is -1. So what we're going to end up finding is that this is actually going to open down, but it's going to be the same distance, the same 149, except this time it's going to be going down. So if we look at x1, x2, or x, y1 and y2, we just go 3, 1, 4, 9. Again, y2 is equal to x1 times a. So the a value is 1. So -1, -4, -9. Okay, and so we're going to make use of our step pattern to identify how to actually graph this. So based on where the vertex is, we know the step pattern. It goes to the right 1 and then down 1 unit. Okay, and that also applies to the left. So we go right 1, down 1, left 1, down 1, right 2, down 4, left 2, down 4, right 3, down 9, right 3, down 9, and then right, and then etc., etc. So we can actually graph this in. Okay, we'll connect these dots. We've got 2, 4, we got 7 points that we can graph here. So we'll graph these together, and then we'll, okay. And so what we've done is we've created a graph that just, it will keep going. Okay, but based on the graph, we can now identify both the x-intercepts and the zeros. So our x-intercept is going to be actually right here. Okay, so where the parabola crosses the y-axis, that's our y-intercept. And so our y-intercept happens at -5. And we can also figure out what our zeros are. Okay, so the zeros happen when the parabola crosses the the x-axis. And so our x-intercepts actually happen at -5, and it also crosses at -1. Okay, so there's 2 different locations for which this particular equation crosses the x-axis. So the two y-intercepts, so 2 x-intercepts.